everyone, welcome to another session of carbon and its compound. In the previous sessions we have already understood little bit about carbon, covalent bonding, allotropes of carbon and versatile nature of the carbon. In today's session I am going to cover organic compounds and hydrocarbons in detail. But before I start today's session, I would like to request you all to kindly subscribe my channel and keep motivating me. If you wish to watch my previous videos, I will be attaching a playlist in the description. So do check them out. So let's begin today's session. Now, first of all, we will try to understand that what are organic compounds. Earlier it was said that organic compounds are the compounds which are directly or indirectly obtained from living organisms. Directly or indirectly obtained from living organisms. And inorganic compounds were said to be opposite of the organic. Inorganic were said to be the compounds which are not obtained from living organism, that is, they are obtained from non-living. Later on, the definitions were changed to more scientific definitions, and nowadays what we say that organic compounds are the compounds of carbon containing usually hydrogen and one and more other elements like oxygen, nitrogen, sulfur, halogen, phosphorus, etc. Halogens are what beta? Halogens are fluorine, chlorine, bromine, they all are called as halogens. Okay. So basically organic compounds have usually carbon, hydrogen along with we are also having any other element. A single element atom can be there or more than that also, but the presence of the carbon should be there. So such kind of compounds are called as organic compound, and the branch of chemistry, that is the field of chemistry where these compounds are studied, they are called as organic chemistry. So the branch of chemistry is called as organic chemistry, and in organic chemistry we study organic compounds. Now a type of organic compound is hydrocarbon. Hydrocarbon is what? It is a type of organic compound which contains only carbon and hydrogen. That is, here you can see the name also. Hydro means hydrogen and carbon is obviously telling carbon here. So these are the compounds having carbon and hydrogen in them, and they are called as hydrocarbons. Hydrocarbons are of various types. Let us see what are the various types of the hydrocarbons. Hydrocarbons and the type of hydrocarbons. Basically, hydrocarbons are broadly classified as saturated and unsaturated. Saturated are also called as alkanes, and they have single covalent bond. Single covalent bond. In our previous session, we have already understood what is a single covalent bond. Single covalent bond means when only one pair of electron is shared between carbon atom. Now unsaturated is of further two types, alkenes and alkynes. Alkynes have double bond between carbon and carbon like this. Alkynes have got triple bond between carbon and carbon atom. That is, here there are three pairs of electron which are shared, here two pairs of electron are shared. Now hydrocarbon is a huge branch because it is having alkanes also, it is having alkenes also, and it is also having alkynes. So basically there are some standards for naming the compounds or the formulas under the alkane, alkenes and alkynes. Okay, so hydrocarbons are named using a prefix and a suffix. Okay, so the name has got two parts. Name has got two parts. Just like our name, we are having name and surname. So in the same way here also the name has got two parts. Beginning part is called as prefix and the other half or the last part is called as suffix, which comes in the end. So if you are discussing alkane, then you will take suffix ane. ane. If you are discussing alkene, then you will take ene. If you are discussing alkyne, you will take yne. So this is the end of the name. Now prefix is decided by number of carbon atom. Number of carbon atom. For example, if carbon atom is 1, we say it as meth. If it is 2, we say it as eth. If it is 3, we say it as prop. Okay, and so on. I'll tell you in the other slide, which is about alkane there. Now let us start with the alkane. Alkane is having a general formula of CnH2n plus 2. Now this is the formula Cn2n plus 2, okay, where N is number of carbon atom. It is the number of carbon atom. Okay. Now, if let us say value of N is 1, let us say the value of N is 1, then put N here, so it will become C1, H2, N value is 1, so 2 into 1 plus 2, so it will be CH4, 2 into 1, 2, 2 plus 2, 4, CH4. If it is 2, so C2, H, 2 into 2 plus 2, so it will be C2H6, 2 2s are 4 plus 2, C2H6. So this is how we are making the formula. Okay, so this is called as formula. Okay, or sometimes we are also calling it as molecular formula. Fine, but now how to give name to them? See, the name has got two parts. First part is prefix, second part is suffix. Now we are discussing alkane, so we will take suffix as ane. Okay, so suffix will be common ane, but prefix will change. Prefix is the number of carbon atom. So if one carbon is there, prefix is meth. So name will become methane. If 2 carbon are there, it is eth. So ane you will attach to it, so it will be ethane. If it is 3, it will be prop. So ane, so it will become prop, prop, ane, propane. If it is 4, it will become but, ane, so you will write butane. If it is 5, you will write pent. For 6, it is hex. For 7, it is hept. For 8th, it is oct. These are very common terms. For 9th carbon, it is nan. For 10th carbon, it is dec. So here it will change to pentane. It will be hexane here. It will be heptane. It will be octane. Ane is the suffix only. It will become nanane. It will become decane. Okay, so the suffix will be ane only because we are discussing alkane, and prefix you will have to learn. That is for 1 carbon it is meth, for 2 carbon it is eth, for 3 it is prop, for 4 it is but, for 5 it is pent, and so on. Okay, now alkanes are having single covalent bond. Okay, among carbon-carbon atoms. Example are methane, ethane, propane. You have already understood that how they have come, from where these names are coming. Okay, so now let us move towards the chart of the alkane. Let us try to make a chart of molecular as well as structural formula of the alkane. Now, number of carbon atom is 1, 2, 3, 4, 5, 6. I am making only up to the 6. Rest of you can try in the home. Molecular formula is CnH2n plus 2. So it will become CH4 first one, carbon is 1. Now here carbon is 2, number of carbon, and it will become 6. Then 3 H, you will put 3 here, 2 into 3, 6, 6 plus 2, 8. Okay. So likewise C4H 10, C5H 12, C6H 14. So this is the molecular formula. Okay, now how to write the structural formula? Keep in mind alkanes have got single covalent bond between carbon atom, and every carbon should have 4 valency, or it is having 4 valency, but it should have 4 single covalent bond around it. Okay, so you will write C here, 1, 2, 3, 4, 1 C and H4. So draw H around it. So this is the structural formula, and the name will become, for one carbon it is meth and suffix will be ane. Right. Now here it is C2. So one C and another C. It should have single covalent bond, which is the criteria for alkane. Now 6 is the H. So one H here, one H here, another H here, fourth H here, fifth H here, and this is the sixth H. Now for the 2 carbon we are having prefix eth and suffix is ane. So it is ethane. Now 3 carbon, 1 carbon, 2 carbon, 3 carbon, H is 8. So one H here, another H here, another H here. 3, this is 4, this is 5, this H is 6, this H is 7, and this is 8. Name will be prop for 3 carbon and suffix will be ane. For C4, 1, 2, 3, 4 carbon and H is 10, 1 H here, another H here, another H here, 3, 4, 5, 6, 7, 8, 9, 10. So here you can write H. Okay. Likewise you can make up to 10. I am only making up to 6. So for 4 carbon prefix is but and suffix is ane. Then carbon 1, 2, 3, 4, 5, and around it place hydrogen 12. This is 12 here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it is pent for 5 and ane is the suffix. Here it is C6, 1, 2, 3, 4, 5, 6. Single bond, and around it hydrogen you can place 1 hydrogen. It is 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So hex and suffix is ane, so hexane. Okay. So now let us go to the next one, which is alkene. Now alkenes are having formula CnH2n. Okay, it is a type of unsaturated hydrocarbon. It is an unsaturated hydrocarbon, okay, which is having double bond. Double covalent bond is present between carbon atom. Example is ethene and propane. Okay, remember name has got 2 parts. One part is prefix, which comes first. Second part is suffix. Suffix is taken from the type of hydrocarbon. So here it will be ene, ene, and prefix for 1 carbon, you know, it is meth. For 2 carbon it is eth. For 3 carbon it is prop. Okay. So likewise here ene, so it will become ethene. This one will become propene. Okay, so the names are written here. Now how to write its molecular formula? CnH2n. Now again n is what? It is the number of carbon atom. Let us say n is 1 here. Okay, now if we will put N here, C is 1, H 2 into 1, so the molecular formula will become CH2. Now if we try to draw this CH2, remember there should be 4 bonds around carbon. 4 bonds should be there around carbon. Now this is carbon and H is only 2, so 1 H here, 1 H here. Okay, if we are drawing one single bond here, then this is not the formula of alkene, because alkene should have double bond between the carbon-carbon atoms, and since here only one carbon is there, so obviously this kind of structure is not possible. Okay, so the series of alkene always starts with ethane, series always starts with ethene, okay, and not with methane. So methane is not possible in case of alkene, so it never occurs. So let us try to make formula and the structural formula for alkenes in the table. Now this is alkene, remember formula is CnH2n. You will need to make double bond between carbon and carbon atom. So number of carbon atom is 1, 2, 3, 4, 5, 6. Okay. Now CnH2n, again we are like the numbering is wrong here. We will start with the 2 here because we have understood that 1 is not possible. So 2, 3, 4, 5, 6, 7. So C2H2 into 2. So it will be C2H4. Okay. Here C3H6. Here C4H8. Here C5H10. Here C6H12. Here C7H14. So these are the molecular formula. Now let us try to draw the structural formula. Remember, you will have to put double bond. Now carbon is 2, so one carbon, another carbon, make double bond. Now for this carbon, 1, 2, there are 2 bonds here, you need to make only 2 more. So one here, one here. So one H will go here, another H will go here. Now for this carbon, one bond is here, second bond is here. Make third bond here, fourth bond here. So H, H. So it is C2, 1, 2, H4, 1, 2, 3, 4. Okay. Remember, around carbon there should be 4 bonds. Clear? It can be a single bond, it can be a double bond, or it can be a triple bond. Now C3, 1 C, second C, third C. Now between these two C, let us make a double bond. So this double bond is for this carbon also and for this carbon also. So this carbon is having 2 here already. It needs 2 more bonds. So place 1 H here, 1 H here. Now this carbon is having 3 bonds. 1, 2 and this is 3. So place another here. This carbon is having only 1 bond. So 1 bond here, other bond here, and this is the another bond. So how many H are there? Count 1, 2, 3, 4, 5, 6. So H is 6 here. Now similarly make for 4 carbons, 1, 2, 3, 4. Double bond you can place anywhere according to your wish. Let us say that I am placing it here. This is a double bond. So this carbon is having only 1 bond. It needs 3 more, 1, 2, 3. So this is satisfied. This carbon 1, 2, 3. So it will take only 1 more. So 1 H here. Now this carbon is having 3 bonds, 1, 2, 3. So it is in need of 1 more only, and this carbon is having only 1 bond here. So it will need 3 more, 1, 2, 3. So you can check with the formula. H is 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Similarly, you can make for C5 also. Okay, you can place anywhere. Let us say now we are placing double bond here. Okay, so this carbon is having 2 bonds here, so it needs 2 more, 1, 2. This carbon is having 1, 2, 3, this is the 4th bond. This carbon is having 1, 2, 3, this is the 4th bond. Okay, this carbon is having 1, 2, 3, 4. This carbon is having only 1 bond here, so 1, 2, 3. Count H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is 10. For 6, 3, 4, 5, 6. Okay. So it is C6. You can place anywhere. Let's say now I am placing here. So this carbon is having single bond here, so it needs 3 more, 3 here. This carbon is having 3, so 1 more. This carbon is also having 3, 1 more. It is having 2, so 1, 2. This is also having 2, 1 here, 1 here, 1, 2. This is also having 1 here only, so it is in need of 3. Now count H. It is 12 here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Similarly, you will make for 7 also. They are very easy to make. Just try. You will be able to make. So these are the 7 carbon. You can place anywhere double bond. I am placing here 1, 2, 3. So it needs only 1. This also 1, 2, 3. It needs 1. 1, 2, 1, 2. It is having 2 here. 1, 2. This is the corner one. It is having only 1. So 1, 2, 3, 4. This is 1, 2, 1, 2, 3. So count the H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it is H14. Now how to give the name? You know that if the carbon is 2, we say it as eth. It is alkene. So we will take the suffix as ene. So it will become ethene. For 3 carbon, we say prop, ene. Then for 4 carbon, bute, ene, butene. For 5 carbon, pent, then ene, pentene. For 6 carbon, hex, ene. 7 carbon, heptene. Okay. So this is, I hope that you are able to understand the alkene. Now let us go to the alkyne. They are also very easy to understand. This is alkyne. Their general formula is CnH2n minus 2. They are having triple covalent bond between the carbon atoms. It is again a category of unsaturated carbon atom. Okay, they will have triple bond between carbon-carbon, and the suffix in the name will be "-ine", alkyne. So YNE will be used. So it is ethyne, propyne. Okay. So in the alkyne also we will try to make the molecular and the structural formula. Number of carbon atom 2. Again in this also from 1 we cannot start, because in 1 we cannot make triple bond. 6 and here 7. Now it is CnH2n minus 2. So C2H 2 into 2 minus 2. So C2, 2 into 2 4, 4 minus 2 2. So C2H2. Okay. Here it will be C3H4. Here it will be C4H6. Here C5H8. Here C6H10. Here C7H12. Okay. Now how to draw its structural formula? Carbon 2, so make 2. You need to place triple bond because it is an alkyne. So carbon triple bond. Now this carbon is having 3 bond, 1, 2, 3. So 4th bond H. This carbon is also having 3 bond, 1, 2, 3. This is H. So C2H2. Here also C2H2. Now C3, 1, 2, 3. You can place anywhere triple bond. This is triple bonds. This triple bond is for this carbon also, for this carbon also. This carbon needs 1 more, so place 1 H here. This carbon is having 4 bonds, 1, 2, 3 and this 4. So there is no need to place H here. We will place H here. 1, 2, 3, 4. So 4 bonding around this carbon, and the formula is C3H4. 1, 2, 3, 4. Similarly, for 4 carbon, 1, 2, 3, 4, you can place anywhere according to your choice. 1, 2, 3. So this is a triple bond here I am placing. So This carbon is having 4 bond, this carbon is also having 4 bond. So no need to place any hydrogen along with them because every carbon needs only 4 bonds around them. This carbon is having only 1 bond, so 1 H here, 1 H here, 1 H here. So the 3 H you have consumed here. Now 1, 2, 3, 4, 5, 6. So H6. Similarly for this one, 5 carbon. Now let us say we are placing here triple bond. So this carbon is having 4 bond, this carbon is also having 4 bond. So these are left 1, 2, 3 H here, 1, 2, 3 H here, 6, 1 and 1 here. So H is 8. Now similarly for the 6 carbon, 5 and 6. You can place anywhere. Let us say now we are placing here this triple bond. So this carbon is having 4 bond, this carbon is having 4 bond. So no need to place H with these carbons. Place them from the corner side first. 3H here, 3H here, 6, 7H here, 8H here, 9H here, 10H here. So now it is for C6H10. Similarly, you can make for C7H12. Now how to give the name? For 2 carbon we use eth. Suffix will be ine, Y-N-E. So it is ethine. Prefix is prop for 3 carbon and suffix is Y-N-E, propyne. For 4 carbon, prefix is but and suffix is ine, butine. Then for the 5 carbon, pent, Y-N-E, pentyne. For 6 carbon, it is hex, Y-N-E, hexyne. For 7 carbon, it is heptyne. Okay, so they are very easy to make, and this is how we are making the series of alkane, alkynes and alkenes. Hopefully you are able to understand by going through this whole session, and let us meet on the next turn. And in the next turn we are going to discuss a very important topic, that is nomenclature. Okay, so nomenclature is basically the naming of the organic compound, and in the next session I will explain that to you. And do watch my videos and kindly subscribe and recommend it to your friends. Thank you.